Now, Abdullah, let's come towards the implementation part of IAC. So which tech stacks would you recommend and which were the best options out there?
Right. So there are different tools to actually enable ISC, right? In terms of purely ISC itself, right? So CloudFormation, Terraform, CDK, CDK for TF, Pulumi. I personally think Terraform is one of the best tools out there because it has an early advantage in terms of early mover advantage as well. And it has a very vibrant community, a very well-written documentation, simplified syntax. And it's increasingly becoming a hot source for top startups to actually deploy their infrastructure or their services as well. So Terraform has a notion of providers where you can register yourself as a provider and then have your implementation done. And then people can use Terraform to use your specific constructs to interact with your services and your offerings, right? And again, this goes back to the point of what is the strategy and what is the decision that actually goes in selecting all of these tools is what are your actual use cases, right? What are your dev teams comfortable with in terms of using the ISC technology, right? Terraform is just one example. But I think there is a key aspect here is that ISC is not the only thing that you need to actually have a fully functional end-to-end robust DevOps pipeline, right? You actually need different actors and orchestration layers that actually apply this ISC to code and the code templates that you have actually written, right? There are different solutions for those orchestrations. We in the past, when there were no publicly available orchestrators, we had custom Jenkins pipelines and things of that nature to actually orchestrate all of our CI and CD, right? These days, there are a lot of different things. You have a concept of GitOps, which is triggered by GitHub Actions or AWS code pipelines, different orchestration mechanisms that essentially allow you to have a robust ISC pipeline. Right. Another important popular open source tool is Spinnaker, which was actually open sourced and developed by Netflix. And Netflix is one of the pioneers in cloud deployments and cloud native application building and releases. They do thousands of deployments and releases in a single day. And that's where they have pioneered this to orchestrated tool as well, which is called Spinnaker, as I mentioned, right? And in addition to orchestration tools like Spinnaker or your custom Jenkins pipelines or your workflows, you essentially need to have different orchestrators across multiple service teams that you have across different organizations and different business units that your company might have, right? Of course, this applies more towards enterprises where you have complex teams and scalable teams where you need these foundational services to work together, right? Which could mean provisioning the network infrastructure or the secrets management solution or the logging or audit trails and all that. But ultimately, ISC on its own just is a tool to enable you to deploy these infrastructures. You need to have well-defined orchestrators and well-structured blueprints of how your environment is going to look like and how ISC code is actually orchestrated and executed by those orchestrators.
So Abdullah, consider that I have a startup. I am building an MVP. I have a monolithic application. Okay. Uske liye what kind of tools that you would recommend me to work with?
Okay, so right. So you mentioned this is a monolithic application and a startup, right? So of course, there are different constraints of different startups in doing the right thing, right? So if that monolith is working and you need more features going into market and it's simple enough where you can just use manual configurations and things, then maybe that is the way to go, right? But if it's at a medium scale, or if you want to roll out features more fast or have better integration tests and decoupling and all that, right, then you essentially need to move towards the ISC pattern. And what ISC allows you to do is, so for monoliths, there is a specific pattern called strangler pattern, where you essentially start at the edge of the monolith and slowly come down to the core, right? So you decouple monolith functionality out of the main monolith and create it into smaller pieces, right? So for example, just create the component that maintains a session, right? Or maintains just the authentication, right? Pull that out, right? Maybe there is another code inside that monolith that does all of the secret management and secret fetching. Pull that out into a separate foundational service, right? And that is a good way to essentially get rid of the monolith and create decoupled, independently performing services, which are independent of the core business logic, and things won't go down burning in one shot. Right, so that's just one way of doing things. But essentially, you have to define a strategy of how you want to decouple your monolith first, right, in terms of functionality, and then build your ISC strategy around it. That, okay, now you know what are the decoupled services that you need for your monolith or your application to function. Let's see how to orchestrate these foundational services through different tools and using ISC to increase the flexibility of achieving that.
Okay, great. So in terms of provisioning, does ISC help?
For sure, right? So we've talked about different ways and different orchestrations, right? So ISC, both your CI and CD can benefit from this, right? Specifically, provisioning relates to CD, right? I mentioned earlier in our conversation that GitOps is a new technology that is taking off, right? What that essentially means, it is built on the premise that all of your infrastructure as code is version controlled and is stored in a centrally monitored and maintained repo, right? And if something changes, let's say in your feature code, right, there are automated actions that take place to validate those changes, test it, build the artifacts, and then essentially push those in required registries. And then your GitOps actions actually trigger your CD part. So now you are essentially decoupling CI from CD as well, right? And once the CI is done, your artifacts are generated, your CD kicks in, and that CD actually knows how to automatically take the configurations, take the artifacts, and deploy them in your target substrates, right? So Argo CD is one of the hottest technologies these days out there that works specifically with Kubernetes-based deployments. But there are other technologies as well that allow you to do CD, right? Spinnaker, you can deploy your custom ISC technologies to do your CD. AWS has code pipeline and code deploy that does all of that stuff for you. But at the end of the day, ISC facilitates everything from integration to deployment. So provisioning is one aspect of that as well.
Okay, so just for the audience, if you can maybe go the topic of CI and CD, maybe just explain it a bit.
Right, so CI essentially means continuous integration, right? And CD is continuous deployment. Continuous integration, what does that mean, right? Historically, you created an application, you have some source code up there somewhere, right? If it's in a repo, then you're already making good strides, right? But the idea is once you have source code of your application, then there are different people or different things that contribute to that source code, right? And it becomes increasingly hard if you do not have a continuous integration strategy to keep track of what changes are coming in, what is breaking something, what is a new feature that broke something else. That's where continuous integration comes in, that as soon as there are new code pushed to the source controls, right, you need to have an integration strategy that actually tests the viability of those push changes with the existing baseline that you have, that, okay, this is how things work. And I'm going to test these things once they come in. So that might involve building or compiling your applications, running all of the unit tests, maybe even running integration tests, right? So all of that becomes the continuous integration. And even the deployment artifacts that are created out of those source code is continuous integration, right? And then the continuous deployment is that once all of this build process is done, okay, people have created their check-ins, code compiled, artifacts generated, how do you actually go about deploying all of this in your target substrates, right? That is where CD technologies come in, right? So Argo CD is one example that I mentioned. There are other AWS code deploy exists, Spinnaker exists, where you can define your custom pipeline stages and workflows that, okay, first deploy on this, then make sure the percentage of traffic is going to the new deployment. If it's all good, then cut over to the new deployment, delete the old one. If something goes wrong, then just reroute the traffic to the original deployment. All of this comes under the CD umbrella.